Finally, I want to talk about taking a matrix and raising it to a power, which we can do so long as it is a square matrix. Let's consider the matrix A, which is the 2 by 2 matrix with elements 1, 1, 1, and 1. Let's take a look at A squared. We know that A squared is A times A, so this will be 1, 1, 1, 1 times 1, 1, 1, 1. We know that we can perform this multiplication because the second dimension of the first matrix is the same as the first dimension of the second. So we're going to end up with a product that is another 2 by 2 matrix. And for each of the elements, we need to take the inner product. So for this one, we're in the first row and the first column. So we take the inner product of the first row and the first column. 1 times 1 is 1, 1 times 1 is 1, and 1 plus 1 is 2. For the next element, we're in the first row and the second column. So we take the inner product of the first row and the second column. Again, 1 times 1 is 1, 1 times 1 is 1, and 1 plus 1 is 2. And in fact, for all of the inner products, we're going to get 2 because all of the rows and all of the columns are 1s and 1s, so we'll get the same thing. So in this case, A squared is the matrix with elements 2, 2, 2, and 2. Now, let's take a look at A cubed. A cubed is A times A times A. So 1, 1, 1, 1 times 1, 1, 1, 1 times 1, 1, 1, 1. We've already actually taken the product of the first two matrices. We know that we end up with 2, 2, 2, 2. And so now we just need to multiply that by 1, 1, 1, 1 to end up with A cubed. When we look at the inner products, for the first element, which is in the first row and the first column, we take the inner product of the first row and the first column. That gives us 2 times 1, which is 2, 2 times 1, which is 2, and 2 plus 2 is 4. And if we go through and look at all of the other inner products, they're going to be the same. So A cubed is going to be the matrix with elements 4, 4, 4, and 4. Let's take a look at A to the 4th power. Here, this is going to be 1, 1, 1, 1 times 1, 1, 1, 1 times 1, 1, 1, 1 times 1, 1, 1, 1, all the ones. And we've already looked at what these the product of the first three is. We know that gives us the 2 by 2 matrix whose elements are all 4. So now we need to multiply that by the 2 by 2 matrix whose entries are all 1s. And we look at these inner products, we end up getting 8, 8, 8, and 8. So A to the 4th power is the 2 by 2 matrix whose elements are 8, 8, 8, and 8. And now I want to ask, what happens if we look at A to the nth power, where n is a positive integer? Well, A squared had elements 2, 2, 2, 2. A cubed had elements 4, 4, 4, 4. A to the 4th had elements 8, 8, 8, 8. We can see that these are all powers of 2, and specifically, whatever the exponent is on A, the element is 1 less than that as a power of 2. So this is 2 to the 3rd power, and then 2 squared, and then 2 to the 1st. So if we're looking at A to the nth power, each of the elements are going to be 2 to the n minus 1st power, because the exponent on the powers of 2 is always 1 less than the exponent on A. So by looking at some patterns, we actually can figure out a general formula for A to the nth power. In the example problems linked below, you're going to see other matrices, and you're going to be looking at powers of those to see if you can find a similar pattern.